The values of incremental rainfall provide the precipitation when determining indices. This is another example for W index. Welcome to hydrology. For a certain water basin, if precipitation occurs, there are water losses and possible runoff if the rain is ample enough. In order to compute for the runoff, we need to make the infiltration constant. This is done in three methods. The first is the phi index, with the concept that the rainfall volume is equal to the runoff volume. The second is the F average method, taking the average infiltration loss throughout the storm duration. The third is W index, which takes the infiltration rate during the time the intensity is more than the infiltration capacity rate. The W index is another method, very similar with the phi index. This method takes into account the initial losses in solving for the infiltration. Mathematically, W index is the precipitation less the runoff and the initial losses, all over the duration of the rainfall excess. That is, W is equal to P minus R minus I sub A all over T. This equation is just like the phi index, only with initial losses subtracted. Graphically, this is subtracted from the first entry. Just like the phi index, there are possibly multiple iterations when looking for the W index, as the procedure is also by trial and error. Every step from the phi index is also observed for the W index, with just an additional step of incorporating the initial loss in the equation. The example contains a record of a certain storm over a water basin. The record consists of time, rainfall depth, and runoff. We are to look for the W index considering the initial abstraction of 5 millimeters. Before delving on the trial and error phase, we are to look for the rainfall intensity, and this we compute by extending the table. First is to assign pulse numbers on the entries. Next is to check the given parameters. To look for the rainfall intensity, we should have the incremental depth and the incremental time. The second column contains values which are increasing. This means time as provided is accumulated. So we place another column for incremental time, then place the first entry as 0. The next entry is solved as 0.5 minus 0, giving 0.5. Then 1.2 minus 0.5 is 0.7. There are also 2 less 1.2, which is 0.8, and 3 minus 2, giving 1. The last two entries are 4.5 minus 3, which is 1.5, and also 1.5 from 6 less 4.5. The next parameter to check is rainfall. The values as observed are also increasing, which means the column is for accumulated rainfall. But what we needed is incremental rainfall, so add another column. The first entry is also 0, followed by 12 less 0 giving 12. 28 minus 12 is 16. 45 less 28 is 17. 60 less 45 is 15, followed by 78 minus 60, which is 18. The last entry is 85 minus 78, and that is 7. With both incremental rainfall depth and time identified, compute for the rainfall intensity. The first entry is still 0, followed by 12 over 0.5 giving 24. 16 over 0.7 is 22.86. 17 upon 0.8 is 21.25. Then 15 over 1 is still 15. The next entry is 18 over 1.5, giving 12. Then the last entry is 7 over 1.5, simplified as 4.67. We can then start with the iteration, where incremental rainfall is used as the precipitation. This was explained in the previous video. The first entry of precipitation is 12, and this is where we deduct the initial abstraction of 5 millimeters. Using the necessary columns, continue with the first trial. We consider all the 7 pulses, using the duration of 6 hours. With the function, precipitation is the summation of the incremental rainfall, which is 80 millimeters. R is the runoff after 6 hours. And since the column is the cumulative runoff, we take the last entry of 40 millimeters. The function then is 80 less 6W is equal to 40. The W index can be computed from 80 minus 40 all over 6, which is 6.67 millimeters per hour. This value is greater than the intensity of the 7th pulse, which means we continue with the iteration. For the second trial, take out the 7th pulse, now working on 6 pulses with a duration of 4.5 hours. Using the same function, solve for the precipitation as the summation of the incremental rainfall, which turns out as 73. The runoff after 4.5 hours is 33. Plug these values into the function, making 73 minus 4.5W as equal to 33. W is then 73 less 33, all upon 4.5, and this is simplified as 8.89. This value is less than any of the remaining rainfall intensities, which means there is runoff with every entry. So the final W index is 8.89 millimeters per hour.